Alrighty, we are on the second page here where you had to work through the first four on scale factors. And I had said yesterday that we would just go over the answers on these first four, and then we'll keep going in the packet. So number one, you should have that the triangle is growing by a scale factor of 2. So you should have drawn a triangle similar to that, showing that 4 centimeters is going to 8 centimeters. So make sure it's labeled. 6 centimeters is going to 12 centimeters. Again, make sure those are labeled so that you can show that this is growing in size by a scale factor of 2. Number 2, this is shrinking because you had a scale factor of 1/2. So you're taking this really long rectangle here and you're cutting it in half. You're dividing by 2. So you're making a smaller rectangle. So you'll do half of 4 centimeters and get 2 centimeters, half of 20 centimeters and get 10 centimeters. Number 3, this is also shrinking in size. So it says, find the scale factor of the similar figures below. So when you look at the larger rectangle, the 10 by 2, notice it's getting smaller and it's going to a 5 by 1. So that is cutting it in half, both sides, and so scale factor of 1/2. So it's those scale factors that are fractions, you use them when they're shrinking, when they're getting smaller in size, those shapes. Number 4, the last one on this first page, finding the scale factor from the first triangle to the second triangle. You're going from a small to a large. It's growing in size. So from 4 to 12, that's getting multiplied by 3. And from 6 to 18, that is also getting multiplied by 3. That is a times 3 scale factor, going from, again, the smaller triangle to the larger triangle. It's growing in size. Okay, so now what you're going to do is turn the page, and we're going to go to the back side of that. And we're going to look at number 5 together. So number 5 says, find the scale factor of the similar figures below, and find the missing side. So you're going to notice you have a small triangle there that have sides of 6 and 8 centimeters. And then you have a larger triangle over here that has a side labeled 36 centimeters, and then you're missing a side. It says X centimeters. So to find that missing side, you're going to use scale factors, what we just learned. So think about what corresponds here. This side of 6 is going to correspond to this 36 centimeters. These two sides right here are going to correspond, and those are proportional to each other. Well, what times 6 is going to give you 36? How much is this growing by? And hopefully you're saying, well, it's getting 6 times bigger, right? 6 times 6 is 36. So if this triangle is scaling by 6, growing in that matter, then here, to find that missing side, remember, if these are similar figures, they have the same scale factors. And so this would also have to be growing by 6. 8 times 6. You would have a side here, a base of this triangle of 48 centimeters. So you're filling in that missing side on that triangle. And you're using scale factor to do it. Number 6, right below it. Again, find the scale factor and then find the missing side. So now you have a rectangle that is shrinking in size. So you're going from a 16 by 48 rectangle to a 4 by X rectangle. And so since this is shrinking, that means this has to be a scale factor of a fraction. So let's look at 16 going to 4. 16 meters going to 4 meters. Well, hopefully you see that this is dividing by 4. So 16 divided by 4 is giving you this 4 meters over here in the smaller rectangle. Remember, we said you don't show your scale factors with division. You show it with multiplication. So if it's dividing by 4, that's the same thing as saying it's times 1/4. It's becoming a fourth of the size, which means it's a quarter of the original size. So if these two sides are scaling down, shrinking by a fourth, down here when we go to find x, the same thing has to happen. So that means, yep, this is also going to go a quarter of the size. It's going to scale by 1/4. Now think about, right? Well, if this is getting a quarter of the size and we understand up here, 16 divided by 4 is 4. What is 48 divided by 4? What would x be here? And this is where if you need to, not saying that you have to, but if you have your calculator, you can use it. 48 divided by 4. What's x? What should this side here be to make these two shapes proportional to each other? Should be 12 meters. So x equals 12 meters. Now both sides are dividing by 4 or becoming a quarter of the original size. Okay, let's look at number 7. So find the scale factor again of the similar figures below, then find the missing side. Now, I want you to take note of what's going on here in number 7. Something should seem maybe off to you a little bit when you look at that. And so maybe take 30 seconds, look at it, think about it, talk to your seat partner, pod. What do you think I should do so I can find that missing side? Do you notice anything? And crew teachers can pause if you need to and talk about it. Can you tell right now which sides are going to match? Do you know which ones are in proportion to each other? And if you're not sure, I want you to think about, is this rectangle right here on the left facing the same direction as this rectangle on the right? It's not. So if you need to, maybe redraw this one. Okay, so what I'm going to do is I'm going to rotate it like this. It's not going to be perfect, okay, but close. So if I rotate this rectangle, that means this is 7 centimeters up top. So I'm rotating it to the right. And over on the left, this is 9 centimeters. And so by doing that, what happens is now I can match a little bit easier which sides go together. So now I can see the top of this rectangle going from 7 to 35. Well, that looks like it's growing in size by 5. It's getting 5 times bigger here. So that would mean then this 9 centimeters is also going to match with this side here, that's x. So if we understand this is getting 5 times bigger in the width, it should be getting 5 times bigger in the length, which means x is going to equal 45 centimeters. Okay. Number 8. So same thing in number 8 as number 7. So if you notice, the triangles aren't necessarily facing the same way. So if you wanted to, because it's confusing to understand which sides are matching up, you could take this original one and you could rotate it around so you see it better. So I'll do that. I will flip this over. Like that. And so this, if I'm rotating it, this is 12 feet here. And this is 18 feet here. Now, I drew that smaller. I didn't mean to, but I didn't have a lot of space. What you need to see is that you're going from a large triangle to a smaller triangle. So you're shrinking in size here. You're going from 12 feet to 6 feet. And so since you're going from 12 to 6, you can see it there that you're shrinking. So think about, well, from 12 to 6, isn't that getting divided by 2? So that means this is half the size of the original. It's shrinking, right? Half the size of the original. Here then, right, if we understand it's shrinking and my scale factor is going to be a half, what is x going to be? We'll cut 18 in half. This side here should be 9 feet. All right, so we just used scale factor on 5 through 8 to understand how to find a missing side on similar shapes. So now you're going to practice this a little bit. You're going to flip your packet over here, and you're going to see this side that says similar figures. So what I did on the right-hand side quickly here is I put a couple notes. If I can a little clearer for you. I put some reminders here as far as what you should be looking at with your scale factors. So if you want to pause and write that down real quick, basically just saying, number one, when you compare your figures, when you're trying to find missing sides, because that's what you're going to be doing here, you're going to be finding missing sides on these shapes, always go left to right. So start with the first shape on the left and compare it to the right. Start with the first shape on the left, compare it to the right. And then, like we've been talking, number two, if you're going from a small shape to a bigger shape, it's growing, and that means you should be multiplying by a whole number. And third, if you're going from a bigger shape to a smaller shape, you're shrinking, and so you should be multiplying by a fraction as your scale factor. So just take a minute, write this down, pause the video, and then we'll keep going here. Alrighty, so let's start looking at a few. So number one, each of these figures are similar, so we just need to find the missing side. And so if you look at number one, you're going from a larger shape, a larger triangle, to a smaller triangle. Zoom it in just a little bit more. There we go. And that means we're going from 12 to 3, and then from 20 to x. And so right up top here, you should see from going 12 to 3 that that's scaling down, it's shrinking. So 12, I know 12 divided by 4 is 3, so this is a scale factor of a fourth. It's getting a quarter smaller, which means I want to make sure in the base here I do the same thing. It's getting a quarter smaller, so 20 divided by 4, x would equal 5. There's your missing side. Second one, number two, you're going from a smaller triangle to a larger, and so this is scaling up. You're going from small to big, it's growing, and I can see right here from 1 to 3 that this is getting 3 times bigger here. And so if this is getting 3 times bigger here, that means it also needs to get 3 times bigger up top. Well, you're missing x here in the smaller shape. So just think about that. What could x be? What times 3 is going to give you 9? Well, wouldn't this missing here be 3? This side length should be x equals 3. 3 times 3, because it's scaling by 3, it's getting 3 times bigger, is 9. And so sometimes that's going to happen. You're going to be missing the side on the first shape, and that's okay. You just have to think and work backwards. So in this first one, this was an example of the shapes shrinking, and that's why you had a scale factor of a fraction. In the second one, this is an example of the shapes growing, and so that's why you had a scale factor of a whole number. So you go and do number 3 and number 4. So pause the video, try the next two, and then we'll come back and see how you did. Okay, so how are we doing here? Number 3. This is growing in size, so this is scaling by 4, so that means x should be 2. So here again, you have an x missing in the first shape, which is fine. X is going to match with 8 And so what times 4 is going to give you 8? Well, 2 does. 2 times 4 gives you 8. X equals 2 right there. Number 4, you should see that this is also growing from the smaller shape to the larger, and this is also growing by 2. This is getting 2 times bigger. It's doubling in size. So that means 5 times 2, x equals 10. Alrighty, so what you're going to do is finish a few more. So I'm going to have you do 5, 6, and then we're going to hold off on 7 and 8. So flip over. And I'm going to have you look at 13, 14, 15, and 16. So I'm going to have you try 6 more problems. 6 more. So on the front side again, you're going to finish 5 and 6. Don't work on 7 or 8 right now. 5 and 6. And then on the back, 13, 14, 15, 16. We still have a little bit more to do. So you can work on those with somebody else in your crew or in your pod, I should say, or by yourself. But we're going to meet back, go over these answers, and then we're going to talk about the next sheet on indirect measurement. So pause the video, work those 6 out for me. All right, we're going back to 5 and 6. Number 5, you should see that these are shrinking, or it's shrinking in size. So from 14 to 2, that's dividing by 7, which is the same thing as multiplying by 1/7. And so that means here, where you're finding x, that, you're going from x to 1. Well, what can you divide by 7 and get 1? Well, 7. X equals 7. 7 divided by 7 gives you 1. So you can always think in terms, if you're shrinking, of what you're dividing by. 14 divided by 7 is 2. 7 divided by 7 is 1. But understand the scale factor is that fraction. So flip it, times 1/7. Number 6, you're growing in size. So 6 times 4 is 24. And so then going from 9 over to x, you also have to grow it by 4 times 4. X is 36. Okay. Go to the last 4 down here. I tried to give you a couple different shapes. Number 13, this is growing in size. So 14 times 4 is 56. And this is where the calculator can come in handy, right, to see what times 14 is going to give you 56. And then 3 matches up with this missing side of x. So if this is growing and getting 4 times bigger, this has to grow and become 4 times bigger as well. X is 12. 14, this is shrinking in size. So going from 90 to 10 is dividing by 9. That means it's times 1/9 as a scale factor. And so x is going to match up with 7 over here. And if I know I'm dividing by 9, what can I divide by 9 and get 7? Well, 63. 63 divided by 9 gives you 7. And so x, your missing side here, is 63. Again, it's 1/9 as the scale factor. 15, you should have x equals 77 because this is dividing by 7 from 84 to 12. So it's times 1/7 as a scale factor. And number 16, this is growing in size. So from 10 to 60, you're multiplying by 6, which means here for x, it should be 5 because 5 times 6 is 30. All right. At any point in time, I didn't say this, but you could have paused, you could have gone back, you could, to write your answers and help understand at any point in time during this lesson. I do want to get into a couple problems with indirect measurement. So now what you're going to do is you're going to turn it and come here. And there are some problems on here about indirect measurement with some stories. And this has to do with, up to number 1 here. This has to do with triangles, meaning we're going to actually kind of draw this out, sketch it out so you see triangles to find the missing side and set proportions up. So let's look at number 1 together. You have a 50-foot apartment building that casts a 12.5-foot shadow, and a nearby building casts a 20-foot shadow. So how tall is the building? All right, so when I draw these, okay, all I'm going to do, so this 50-foot apartment building here, is I'm just going to draw like a rectangular shape like this and have a shadow coming out like this. Okay, so here's the building, here's the shadow. And I'm going to label it, this is 50 feet, and the shadow is 12.5 feet, 12.5. I'm getting that right from here at the beginning of the sentence. A nearby building casts a 20-foot shadow. So that shadow is larger than this shadow from this building. So now I'm going to draw a little bit longer shadow, and I'm going to label that 20 feet. And it's a nearby building. So if the shadow is bigger than the first one, that means this building is also going to be bigger. I'm going to draw a bigger building here. And this is what we don't know. This is what we're going to call X right here. So now what we're going to do is we're going to match corresponding sides and set a proportion up to find X. So 50 feet and X go together, right? So I'm going to make that my first fraction. 50 feet over X equals. Okay, next fraction. 12.5 goes with 20. 12.5 feet over 20 feet. So I did 50 over X, 12.5 over 20. I'm matching the buildings, small to big, and I'm matching the shadows, small to big, and setting that proportion up. Okay, so now you know with proportions we have to cross multiply. We're going to do 12.5 times X, 12.5X equals. And then over here, 50 times 20. So when you multiply 50 times 20 in your calculator, you should get 1,000. And so now we got to solve for X. So we're going to divide by 12.5. Divide by 12.5. Okay, so X equals, so go ahead and divide that out. 1,000 divided by 12.5. And see what you get. You should get that X equals 80 feet. So the height of the building, the nearby building, is 80 feet. Number 2, a 8-foot tall stop sign casts a 3-foot shadow. A nearby man is 6 feet tall. How long is the man's shadow? Okay, so 8-foot stop sign. I'm just going to draw a skinny little pole here for the stop sign, 8 feet. I'm going to draw that shadow out like this, 3 feet. And then a nearby man is 6 feet. So the nearby man is smaller, just a little smaller than the building. He's 6 feet or tall. It has a shadow coming out. And so you don't know the shadow. So we're going to match sides here. So 8 feet and 6 feet, the height of the building and the height of the man are going to go together. 8 feet, 6 feet. And then put the shadows together. So 3 feet and X. And solve that proportion. Find that shadow that's missing there. So I'm going to do 8 times X. 8X equals. 6 times 3? 18. And so divide by 8. Go ahead and solve it. X equals, what is the height of the man's shadow? And if you get a decimal, leave the decimal, don't round it. So you should have the shadow is 2.25 feet. 2.25 feet. So I accidentally drew the shadow, I think, a little too long. It should be shorter than that one. Didn't mean to. 2.25 feet. There's X. There's the man's shadow. So what you're doing is you are comparing similar figures. So if I come back up to number 1 and I draw in a dotted line on both of those, these are triangles, right? So you're comparing similar triangles. Same thing with number 2. Draw that third side in. So you're comparing similar triangles and using proportions to find the missing side. You're not using scale factor this time. You're using proportions to find what's missing. And remember, with similar figures, you can use scale factor, but you can also check to see that they're in proportion to each other. And so that's how you're doing these indirect measurements. So I'm going to have you try number 4 and number 5. Okay, try those two. Check back when you're done, and then that'll be the end of the video today, or the end of the instruction today. So finish 4 and 5. You may work with somebody again if that's okay with your crew teacher, and then so pause the video. When you're done, check back for the answers, and then we'll be all set. And I will see you back on Monday. So have a wonderful weekend, and we'll see you Monday.